The number of outlets you can safely install on a 15-amp breaker with 14/2 wire depends on several factors. Firstly, all outlets are assumed to be standard 15-amp outlets. Secondly, all wires must be properly sized and installed according to electrical code, such as 14/2 wire for 15-amp circuits. Thirdly, wire connections must be secure and made with appropriate connectors. Finally, the circuit should not be overloaded with other appliances or devices. The National Electrical Code, known as NEC, requires a minimum of one receptacle outlet for every 12 linear feet of wall space along all usable wall surfaces in habitable rooms. Based on this requirement, the maximum number of outlets that can be safely installed on a 15-amp circuit, assuming there are no other appliances or devices using the circuit, is calculated as follows: 15-amp breaker divided by the current draw per outlet equals the maximum number of outlets. The current draw per outlet is 1.5 amps for standard 15-amp outlets. Therefore, 15 amps divided by 1.5 amps equals 10. However, to ensure safety and prevent overloading, the NEC allows for an additional 25% capacity. Therefore, the maximum number of outlets that can be installed on a 15-amp circuit is 10 outlets multiplied by 1.25, which is the 25% allowance, equals 12.5 outlets. To be conservative, it is recommended to limit the number of outlets to 14, which is rounded down from 12.5. It is important to note that this calculation does not take into account any other electrical devices that may be plugged into the circuit. Therefore, it is always important to ensure that the total current draw does not exceed the capacity of the circuit. In general, the NEC recommends that you do not load a circuit to more than 80% of its capacity. For a 15-amp circuit, that is 12 amps. This helps to prevent nuisance tripping of the breaker. Remember, electrical work can be dangerous. It is important to consult with a qualified electrician if you are not comfortable working with electricity. It is also a good idea to check with your local building codes to see if there are any additional requirements for electrical work in your area. Factors that determine the number of outlets. Standard outlets. The calculation assumes standard 15-amp receptacles. High-demand devices, even if plugged into standard outlets, can significantly increase the load. NEC guidelines. The NEC dictates the minimum number of outlets based on wall space. The 1 outlet per 12 linear feet rule ensures reasonable access to power. Continuous load circuits loaded for 3 IOs or more are considered continuous loads and require additional derating. Other appliances sharing the circuit, such as lights, fans, or small appliances, affect the number of available outlets. Voltage drop. Excessive voltage drop can occur on long runs of 14/2 wire, especially when heavily loaded. This can affect appliance performance and efficiency. Best practices. Reduce load. Use energy-efficient devices and appliances to minimize current draw. Balance circuits. Distribute outlets across multiple circuits to avoid overloading any single circuit. Consider future needs. Plan for future electrical needs when designing circuits to avoid overloading later. Consult an electrician if you are unsure about electrical calculations or wiring. Consult a qualified electrician. Additional considerations. Dedicated circuits. Certain appliances such as refrigerators, microwave ovens, and washing machines require dedicated circuits. This means that they should not share a circuit with other outlets. Lighting load. Lighting fixtures also contribute to the overall load on a circuit. LED lighting is more energy efficient than incandescent lighting and can reduce the overall load. Small appliances such as toasters, blenders, and coffee makers can draw a significant amount of current. It is important to consider the current draw of these appliances when calculating the number of outlets on a circuit. Extension cords. Avoid using extension cords whenever possible, as they can be a fire hazard if overloaded. Instead, install additional outlets to meet your needs. Surge protection. Use surge protectors to protect your electronic devices from power surges. Common mistakes. Overloading circuits. Overloading a circuit is one of the most common electrical mistakes. It can lead to overheating, fire, and damage to appliances. Ignoring NEC codes. Ignoring NEC codes can result in unsafe electrical installations and potential hazards. Improper wiring. Improper wiring can cause electrical shocks, fires, and equipment damage. Neglecting maintenance. Neglecting electrical maintenance can lead to deterioration of wiring and equipment, increasing the risk of electrical problems. Tips for electrical safety. Use GFCI outlets. Ground fault circuit interrupter. GFCI outlets protect against electrical shock in wet locations such as bathrooms and kitchens. Inspect cords regularly. Inspect electrical cords for damage such as frayed wires or cracked insulation. Replace damaged cords immediately. Turn off power before working on electrical circuits. Always turn off the power at the breaker box. Use proper tools. Use insulated tools when working with electricity to prevent electrical shock. Hire a professional. If you are not comfortable working with electricity, hire a qualified electrician. In summary, determining the number of outlets on a 15-amp breaker with 14/2 wire involves considering factors such as standard outlets, NEC guidelines, continuous loads, appliances, voltage drop, and best practices. Remember to reduce load, balance circuits, consider future needs, and consult an electrician if needed. Additional considerations include dedicated circuits, lighting load, small appliances, extension cords, and surge protection. Common mistakes include overloading circuits, ignoring NEC codes, improper wiring, and neglecting maintenance. Finally, follow tips for electrical safety such as using GFCI outlets, inspecting cords regularly, turning off power, using proper tools, and hiring a professional if needed. Electrical codes and best practices are essential for ensuring safe and efficient electrical systems.